Hey there guys, today I'm going to walk you through some examples of how to factor a quadratic trinomial when a is not equal to 1. So let's make sure we remember what each of these pieces mean. So quadratic refers to the fact that that lead term has an exponent or a degree of 2. It's a trinomial because we have 3 terms, and a is not equal to 1 because a is that coefficient right there in the front, and it is obviously not equal to a because it's equal to 6. So the very first step that we always use no matter what polynomial we're factoring is we look for a GCF. So I need to see if there is a common factor I can factor out of each of these terms, and there is. These are all even numbers, so I can factor a 2 out of each of them. So the first thing I'm going to do is factor out that 2. So 6 divided by 2 leaves me with 3n squared. That 40 divided by 2 is going to leave me with 20n, and negative 14 divided by 2 leaves me with a negative 7. So now I'm going to look at my step 2, and for lack of a better term, I'm going to call this section here inside of the parentheses the leftovers, okay, because it's kind of like what I have left over after I factored the greatest common factor out of there. So the leftover has an a that is not equal to 1. So I've still got an a that's not equal to 1. So I'm going to have to use something called the AC method. And here is what we're going to do to find. So AC method starts off by first of all multiplying a times c. So I'm going to take my a value and I'm going to multiply it by c. So in this case, a is 3, c is negative 7, because I've got my a is 3, c is negative 7. So a times c equals a negative 21. The next step is that I need to set up a table. Okay, so I'm going to set myself up a little table here. So step 2, after I've multiplied a times c, step 2 is that I'm going to set up a table. And on the left side of that table is I'm going to figure out what are the numbers that I can multiply to get a times c. So in this case, a times c is negative 21. So what are numbers that I can multiply to get AC, in this case, negative 21, but those same numbers also need to add to get B, which in this case, B is, of course, 20. We know that up here from the original problem. So I always just like to go in order when it comes to the factors to make sure I don't forget one. So 1 times 21 gives me 21, but this is a negative 21, so that means that one of them needs to be a negative. So one option is for negative 1 times 21. Another option is a positive 1 times a negative 21. Next I could do, let's see, 2 isn't a factor of 21, but I can do negative 3 times 7, or positive 3 times negative 7. And I believe that does it for all the factors of 21. So let's see if any of those sum up to 20. So let's start off with negative 1 plus a positive 21. Oops, there we go, my very first one. Negative 20 or negative 1 plus 21 is also equal to positive 20. So those are my two numbers I need right there. So what multiplied to get negative 21, that also adds to get 20. So what am I going to do with those numbers? I am going to take my leftover, okay? So I'm going to take this, that 3n plus 20n minus 7. I'm going to bring it down. So that 3n squared plus 20n minus 7. And I am going to split the middle term into two terms. So I'm going to take this negative 20n and I'm going to use the numbers from step 2. So using step 2. So that negative 1 and that positive 21 are what I'm going to use to break that positive 20 into two pieces. So that 20n is now going to be broken up into negative 1n plus 21n. So I'm going to bring the rest down. So what would be the whole point of taking that trinomial and breaking it up into extra pieces so that now I have 4 terms? Well, the whole point of doing that is so that now I can factor by grouping. And if you've forgotten how to factor by grouping, remember I do have a video to remind you how to do that as well. I'm going to assume you know what you're doing, so I'm going to go ahead and take care of that. So remember, I'm going to take those 4 terms and I'm going to group them into 2 groups where I can factor out a common factor. So in this case, I can factor an n out of those 2 terms, and here I can factor a 7 out of those 2 terms. So then you factor out that common factor. So that's going to leave me with 3n minus 1. I'm going to factor out the 7 out of the second group, and that leaves me with 3n minus 1. I know I'm on the right track because I have this common set of binomials right there. So I'm going to factor out those common binomials, and remember that the n and the 7 go into the other binomial. So my fully factored form is 3n minus 1 times n plus 7. But there's one little tiny detail I want to make sure that I don't forget. Remember, way back up there at the top, remember I factored out that GCF in my very first step? Don't forget your GCF. So that 2, it's been hanging out there pretty much not doing anything, but it's still there. So make sure that you bring down that GCF that you factored out in the very first step. Okay, example number 2, it's going to work exactly the same way. My very first step is always to look for a GCF. In this case, I don't have a greatest common factor. There isn't anything that can be factored out of both of these terms, or all 3 of those terms, I'm sorry. So in this case, I don't have a GCF. So now, because A is not equal to 1, so we're going to have to use the AC method. So remember, I need to do A multiplied by C. So in this case, we're going to do 9 times 4, which is going to give you 36. So when we set up our table, we need to figure out what can we multiply to get AC. So what can we multiply to get 36 that we can also add to get B, which in this case is a negative 12. So let's start off by figuring out those factors of 36. And because I see that whatever the numbers I come up with have to add up to a negative, that's a pretty good guess that I'm going to be multiplying 2 negatives together, because obviously a negative times a negative will give us a positive 36, but a negative plus a negative will also add up to a negative 12. So I'm just going to go in order to make sure I don't forget any factors. So negative 1 times negative 36 certainly don't add up to negative 12. Negative 2 times negative 18 don't equal negative 12. Negative 3 times negative 12 do not equal 12. Negative 4 times negative 9 Those don't add up. 5 doesn't go into 36. I've got negative 6 times negative 6. Alrighty, well there are our two terms that we needed, or our two numbers that we needed, because negative 6 plus negative 6 also equals negative 12. So remember, you need to take that original trinomial up there, so that 9n to the second minus 12n plus 4, and you're going to use those terms from that table to break that middle term apart. So it's going to be negative 6n plus negative 6n. I'm going to bring the rest of it down. And now we're going to factor by grouping. So remember, to group, I'm going to group those two together, and I can factor a 3n out of those two. I can factor those two together and factor out a 2. So out of the first set, if I factor out that 3n, that's going to leave me 9 divided by 3, of course, is going to leave me with a 3n. 6 divided by 3 is going to leave me with a negative 2. And then the n's are just going to cancel each other out, so I'm just left with the n by itself. If I factor out that positive 2, negative 6 divided by a negative 6n divided by a positive 2 leaves me with a negative 3n. And then positive 4 divided by 2 leaves me with a plus 2. Now, you notice that I don't have a common binomial here like I need in order to be able to factor that out. They're almost the same, but not quite. So here is how I'm going to adjust that. In my previous step, instead of factoring out a 2, I'm going to factor out a negative 2. And let's see how that gets me what I want. Because now, so I factored out a negative 2. So I'm going to get rid of this. So let's see how flipping that sign helped me out. Because now I'm doing a negative 6 divided by a negative 2, which leaves me a positive 3n. And then a positive 4 divided by a negative 2, which leaves me with a negative 2. So that means that now I have that common binomial that I needed in order to be able to factor it out. Because now I have 3n minus 2 in both places. So I'm going to factor out that 3n minus 2. And then the 3n is going to come out there. The minus 2 is going to become that part of my binomial. And so I'm left with the fully factored version of 3n minus 2 times 3n minus 2. Frequently you see it written like this, because you notice it's exactly the same two binomials multiplied by each other. So we do frequently write it like that as well, to represent the fact that 3n minus 2 is multiplied by itself twice.